Hello. Okay. Hi everyone. Okay, I got a piece of advice from a speaker last night. So if everyone could look at me right now and give me a big smile. Brilliant. I feel more nervous. They lied. Okay, so I'm here to talk to you about trunk-based development and continuous deployment. And these are kind of two practices that I hear a lot of people talk a lot about, but from my chats with other developers in Dundee, they're not that widely adopted yet. So, why am I here? Why have I flown 1,022 miles, 2 flights, a crazy sprint through Schiphol Airport to be here with you? It's because, I really feel that this is something worth sharing with you. It's really important to me personally, because I'm angry. I really am. Who here is mad about merging code? Because it's boring, right? Who here is bored of broken builds? Come on, somebody's going to be bored of broken builds. Frustrated with flaky tests. Anyone? Oh, come on. Right. Yeah, so there's loads of stuff in programming that's just really annoying and is toil and is terrible. And I'm going to talk about how these practices might help that. So why do we make software? I'll just leave you with that for a second. Think about that in your head. Okay? It's to help users achieve goals and needs. That's it. You are building software for someone else because they want to achieve something. Okay? But we were not. When I joined FindMyPast, we were definitely not. But about 3 years ago, we had a new CTO join, and we were in the really fortunate position to have somebody come in who really wanted to support change, who really wanted to help us modernize and start serving customer needs. To give you a little bit of background, we're kind of a dev team of about 45. We're in the genealogy space, so a big scale website. And our competitors, our main two competitors, they're 4 times the size and 10 times the size of us. They were growing 20% year-over-year growth. They were flying, but we were not. But we had all the same elements as them. But why could we not go as fast as them? So we made some decisions. So the first thing I want to talk to you about is types of work. So there's this kind of model where there's 4 types of work. So over here we've got firefighting. So you're responding to an incident. You've got toil. So toil is all that stuff that I was talking about, where you're, like broken builds, flaky tests, anything, that you're doing that you don't end up delivering real value. It just feels like you're spinning your wheels. So on the right-hand side, we've got innovation and improvement. Improvement is so important to reducing firefighting and toil, and that's got to be supported. And if you want to go fast, you have to dedicate time to improvement, and then that will make time for the fun stuff of innovation. So yeah, FindMyPast dev team, we initially focused on improving flow. So this is the 3 ways of DevOps. So you increase your flow to production, where you've got operation, you get feedback back, and you've got the continuous learning in the middle. So that's the 3 ways of DevOps. This is about improving flow. So we made a pretty big architectural decision at the beginning, which was single product, single code base. And what do I mean by this? So up here we've got our customer. Our customer views us as a website, as a single product. But we viewed ourselves as 4 products. So we've got everything under the www subdomain. You've got a team here. This was like e-commerce and membership. You've got search. So we've got a search database with 3.7 billion historical records, another team there. You've got the family tree app, so this is where people come and build their family trees, another team. And then there's kind of blog content, marketing content for getting users in. So this is how we treated ourselves as 4 products, but actually the user doesn't care. They're like, you're a single product. But down here, this created some interesting stuff. So if you wanted to create a user journey, you needed all 3 of these running at the same time. That was 3 big monoliths. That was like 3 really difficult code bases to get running together. And then the same again down here. If you wanted to schedule work between the teams, you've got all that complexity of communication and scheduling and everything like that. And I believe that this contributed in large part as to why we were so slow. So we made a change. We decided to go for a monolith. 1 monolith, not 4. So here we've got our presentation layer, we've got a single API that talks to the platform, and we have vertical stack teams. At this point it's worth, that's a later point. So this is the architecture that we went for. This is a kind of a Node.js based app, React.js component based, which is really good for separation of concerns, very good declarative way of building user interfaces for those who are interested. Down here we've got the Marshall. We decided to go with GraphQL because it gives you a really nice separation of concerns. And then downstream of that, various services. So the next thing that's worth talking about is extreme programming. Who here is aware or even has read the Extreme Programming book? Cool, so a few people, that's great. That was written in 2004, or that was the 2nd edition. The original was 99. So 14 years on, it's the learnings from extreme programming are so valuable. So we had this new CTO, Andy Mendelsohn, come in, and he made some changes, some pretty drastic changes. So no more working on your own. We all had to pair all of the time. So that was a pretty big change for us. We had testers and we had front-end engineers which were just doing HTML and CSS. Everyone just became an engineer. We had specialisms, but everyone just became an engineer. There were no longer silos. And this was important because this is part of the kind of the cultural changes that we went through. The other things with extreme programming is we really focused on the continuous integration and a lot more test first, TDD. So finally, we used some information from the State of DevOps report. So this has been mentioned quite a few times. So this is from Nicole Forsgren, Jez Humble, and Gene Kim, and Puppet for a while. But this is what kind of prompted us to really look hard at trunk-based development and continuous delivery, or in our case, continuous deployment. Because this was statistically sound work. This said that if you adopt these practices, this will lead you to becoming a higher performing IT organization. I did a statistics degree at university. I believe in that stuff. I looked at the data and I thought, yeah, this actually makes sense. So, finally, this is why I'm here. I'm here to talk about going fast, about, we were really slow. We were being massively outperformed by our competition. And a lot of that was down to how we operated as an engineering team. So I've kind of laid out a lot of change that we implemented in rather short order, and this was about 3 years ago. And then I'm going to go into these practices of trunk-based development and continuous deployment and the things that we've found out along the way. So, trunk-based development. I've got a short story about my history. So, as mentioned, I was in games development for about 7 years, 7 years. And from 2006 to 2010, I spent 2 days a week merging code. And yeah, I was just totally normalized to that. That was just like, yeah, that's just how dev is done. And that might sound crazy, but there were 100 developers on that team, and a lot of people were in that same boat. So much so that we had a full-time merge engineer. So we had the mainline trunk, we had team branches, so there were maybe about 7 or 8 team branches, and then off that, everyone had their own little personal branch. And those, and then we even had this thing called the merge hat that you pop on top of your head, and that means you're merging to your team branch, so nobody else can merge at that time. And it's just so much wasted time, wasted resource. Well, why does that happen? And what's trunk-based development got to do with that? Well, I think that if you adopt trunk-based development, you can really just get rid of the cost of merging almost entirely. So, what is trunk-based development? It's developers collaborate on code in a single branch called trunk. It sounds really simple. But here's your constraint: no branches. And that's a bit scary. Up until about 3 years ago, I was in that world of, you build your feature branch, you write your code, and you do your stuff. So this is really the only difference. So you make your branch, you get your ticket, you write some software, you commit that to your branch, and then you merge it back to master. That's kind of feature branching as it is right now in a simple form. So that branching doesn't really go away, but what you have instead is a feature toggle. So your branch is in code rather than in Git or Mercurial or whatever. You write your software and you commit to master. That's it. You take the complexity away from the merging and you trade it off, and you say you get the complexity in your code. And that's basically it at a really simple level. And this is our architecture for feature toggles. So we've got our user experience up at the top. That is where the toggles live. That's where they say, this, not this. Then that talks to a toggles API. The toggles API uses information about our user, which is done from a series of downstream API calls. So you get a big chunk of attributes about the user, and then you say, at the toggle level, I want to apply this toggle to this subset of users, and that's how you can do a canary release. So we have a preset cohort, which is people with like a findmypast.com email address. And if you go to the production website, you can see features that aren't yet released to the public, because they are, so there's a benefit to feature toggles as well, in that you can decouple your deployment from your release. So we can deploy, but we aren't actually releasing those features to users. Now that's some additional complexity that you can take on, but I think it actually speeds you up. And LaunchDarkly is our partner, or the service provider that provides the toggles interface. They've been rock solid for us. So the second constraint in trunk-based development is a frictionless development experience. And I wasn't sure about whether to put this in or not, but I really thought it was worth talking about because it's been vital to our success in adopting trunk-based development. So we support Apple, Windows, and Ubuntu as development environments. Kind of just let people choose what they want to do. So the designers are using Apple's, the front-end specialists, same again. And then we've got small .NET stuff, so you need Windows for that. And some people enjoy, like all our new stuff is kind of Node.js based, so they enjoy using Ubuntu for that. So we have this development environment that we need to support across platforms. So we thought, what do we do first? Let's do it in Docker, because that'll work, right? It didn't work for us because it was too slow. The feedback for the developers was too slow, the debugging was too hard, that kind of stuff. So actually we went native and just used Node.js to Node.js and the Node.js scripts. They have really amazing support across platform. But again, it was too complex. And what we ended up having to do was build this application here. So this main UI code base is used by 30 developers every day. And we're wanting them to commit and push code to master like as soon as they are ready to go. And what this does is it's got API, client, server, tests, JavaScript tests, style, canopy. All of this stuff is what you need in order to develop in that code base. And it's literally a single command, npm start, this loads up. It's got all the file watchers, and anytime you're making changes in the code, it will rerun everything. And this is a really important thing for the developers to get that fast feedback and to be able to ship their change with confidence. And then the third constraint of this is to keep the pipe green. So what do I mean by that? We had a problem where we had developers committing code on top of a broken continuous deployment pipeline. And that was less than ideal, because then you know, like you're trying to fix the pipeline and there's just more code coming in on top and that kind of stuff. So we were trying to stop that. So what we did is we shifted left and we put in a bunch of checks prior to you being able to push code. So this is done with Git hooks. We use a library called Husky.js that allows you to write logic in JavaScript, and that gets executed as a Git hook. So we have stuff on commit messages, on push, on a bunch of stuff. So what does that do? So when you do git push, the first thing is it executes the hook, which executes this verify step where it verifies your code. But what does that do? So first of all, it checks this dashboard's up and running, and then it checks that everything is green. So along the top, you've got all the services. Everything has to be passing. You cannot push code unless it is passing locally. Then there's a bunch of smoke tests that run. So that's kind of a battery of tests against the UI. And then finally, schema tests. So because we're using GraphQL, you can compare your local schema versus your remote schema and check if you're going to break anything. It's kind of like consumer-driven contracts. The next thing that we do is we check the CI pipeline. So we use TeamCity. We say that build and test and the critical path tests have to be passing in order for you to be able to push code. If they're not passing, they need fixed first. And then finally, you push. So what does that end up with? A pre-push pipeline. That has been absolutely vital to us to ensure quality prior to pushing that code up to master. I can't stress enough how important this is, that you have that quality gate. So much so that we're like seriously looking at removing our unit tests from the critical path on the server because we know that they've run on the client. And that's going to save us like 4 minutes in build time and get our deployments down to 6 minutes, which is pretty cool, right? So on to continuous deployment. Every change goes live immediately and automatically. It sounds a bit scary, and we just kind of went for it, which, you know, not everyone can do that, but we were in a state where the business was keen for us to move faster, so we just went for it. But the first constraint that we've kind of imposed upon ourselves is don't break production. And we've done this with what we call critical path tests. So these are like the Selenium browser clicky button tests, but a subset of what we could do. This is the critical user interface tests that impact revenue. And we need to make sure those are working. So there's just kind of one thing that I think is worth mentioning here, is that these can be really flaky, and if you don't trust them, they are not worth anything. So you have to trust these tests. And the way that we did that is we built a resiliency gauntlet. So anytime somebody wants to author a new critical path test, that test goes through what we call the resiliency gauntlet, where it has to pass 50 times in a row with 0 failures. And for a Selenium test, that's actually quite hard. If it can pass that, it gets promoted to production. If a test becomes flaky, it gets taken out and put back into the gauntlet, and somebody has to go and fix that. We need to trust these implicitly, and we don't want to be constantly fixing them, because that is wasted time, that is toil, and that is not innovation. So the next constraint that we've imposed upon ourselves is recover instantly. This is clearly impossible, but it's good to have a goal, right? Toggles and rollback. So the first thing I want to talk about is toggles. Toggles can instantly turn off a feature or thereabouts. It takes less than a second to turn something off from when you're in the user interface and launched Arcly, doing that toggle, to when that gets turned off in production for all users. So that's been really useful as a mitigation thing. The second thing is rollback. So as it Michael Rook mentioned yesterday about additive changes to databases so that you can roll back your code and the previous version of the code works against the database. That's important too. On all of our code bases, we have a rollback step on the CI so that any engineer can just go to it and select the previous version and roll it back. So that's important too. But probably more important to recovering quickly is the training and the learning. So training-wise, if somebody doesn't know where the toggles are, if they don't know how to roll back the builds, if they are dealing with an incident in real time and you've not trained them how to do that quickly, you don't want a firefighter coming to put out a fire in your home if they don't know how to handle how to put out a fire. I can't stress this enough. Training your people and giving them support is really important. And also learning. So, kind of bang on about this, but the post-incident reviews and making sure that you take the remedial actions afterwards to make your system more resilient or more anti-fragile is really, really important. And then the final one, which is no manual configuration to continuous deployment. So you have your app. Your app talks to a bunch of different other things. It's really important that, well, I think it's really important that you can configure all of these things automatically, and from your repository. So, like you've got your Docker file. That's an example of this. But if you need to connect to any of these things, I would say put that configuration in your repository and have that run as part of your continuous deployment pipeline, so that you can have a reliable and maintainable state. Because if you're having to go off to the alerting system and manually add alerts, then you've got two systems out of sync. And if that's not an automatic step that's done as part of some pipeline, then you can get differences and it can be dangerous. So, measurement of continuous deployment. The things that we measure are deployment lead time, so that's the time from when a developer commits on their machine to when that commit is deployed in production. We were doing pretty well at around 40 minutes for quite a few months, and then recently it's jumped up to 120. The reason for that is we're doing a Kubernetes migration, and it caused a lot of problems and a lot of broken builds and a lot of batched up stuff that didn't get through. So, but that's a good health metric that you can measure to check that how effective is our trunk-based development and our continuous deployment. Are we getting our changes out quickly? Can we respond? And then finally, deployment frequency. So this is the number of deploys per developer per day. So we take the number of engineers, the number of working days, so that gives you a total working days, and then we do a total production deployment, and that's what that ends up being. And we're kind of aiming for 1. Generally, people are happier when it's about 1. We see when it starts dipping down, you see that come up a lot in the retrospectives, that people are complaining that they can't ship their work and that they're getting annoyed. So, the final part of my talk is about supporting your team through change. So adopting these practices isn't easy, and it's a huge amount of work, and you really need to support your team, because change hurts. Nobody really wants to change. So this is the Kubler-Ross. It's called the 5 stages of grief, but it's also applied to change. And you can use this as a model to help your people through change. The first thing that happens is you get a shock, that you're like, oh, I'm going to have to change. And then you deny it. You're like, nah, it's not happening. This won't happen. And then you get into the angry state. I was right there. I remember when I went from Git flow to GitHub flow, and I was like, no, I like all my branches. Don't take them away from me. I got quite angry about it. And then you come down to letting go. You realize that this is happening. We have to go for it. And it's at this point that if your change is unsupported, you might get a bunch of people just coming off and leaving the business here. Which moves up to experimentation. You're kind of feeling a bit anxious about it, but then it maybe starts working, you start feeling a bit more optimistic, you accept the change, and then finally enthusiastic, and you give a talk about it. So I'm here, yeah. I love continuous deployment. Anyway, this is called the Valley of Despair. Help your people through this. If you're not, it's, this is what will help. And my only advice here is to run these things as pilots. If you say, we're going to trial this new thing, we're going to do it as a 4-week pilot, and then we want your feedback, help us. That'll help to really level that out, and you won't get the anger, and then you might just kind of go across here in a nice shallow arc. So, support change with dedicated resource. Something that we figured out quite quickly was that if you notice here, there is no single owner of this. And that actually posed a pretty big problem, because you've got a bunch of different developer teams, product development teams, and they want to ship their features, but they were also having to kind of do the work on building this out, on setting the patterns. And that's really difficult to do in a decentralized nature where you've got to get 4, 5, 6 teams to all agree. So what we did was we have 2 support teams. All our teams have names, but this team is called Prometheus. They own the front end, or at least the operation of the front end. They own the developer dashboard to make sure that works, and the Marshal, so that kind of API there. And they facilitate taking feedback from all the teams. They train the teams, and they keep ownership of this. And that was a big change for us. So we did that about a year in. About 1 year in, this was going really wrong. Everyone was really angry. We implemented a pair, which became Team Prometheus. And that quickly, within 3 months, solved almost all of the pain, and everyone went from being really, really big detractors to really positive about it. And then on the other side, we've got the Spanners team, which is infrastructures, tools, continuous deployment pipelines, and they kind of own all that kind of stuff. And that's been really useful for setting out standardized patterns to just let the product delivery teams get on with it. Support change with time to learn. So we give everyone an hour a day to learn at Find My Past. And that's mainly freely directed, but when we bring in a change, for instance, like bringing in Kubernetes, we set out a kind of a series of tasks that somebody has to do. It maybe takes about a week's worth of learning time, but that gets them up to some kind of base level of skill, and that's worked well for us. So, support your people, give them the time to learn this new stuff. And yeah, that's me. Let's go fast, continuous deployment, trunk-based development. Don't spend your time doing all the toil, get rid of it, adopt these practices that are proven to work, and go faster. So, thank you very much.
Oh, yes. Hello, thank you for a nice talk. I have one question. Do you measure unused code in your production? Like all the feature toggles that are permanently off, and do you clean them up? Yes,
we have a Slack bot that we call toggle nag, and toggles have 30 days. You can make them permanent, you can make them operational toggles, But most of the time it's just a 30-day toggle, and if you're not done with it by then, toggle nag breaks the build and makes somebody either delete it or give it another 30 days.
Has the average commit size changed at all?
I've not measured it. Sorry, I don't know. Okay. Oh, one more, or no?
All right, one more. So he's having better, yes, all right.
Hey, I was wondering about those pre-hooks. Are actually, did I understand correctly, are developers now using this pre-hook approach to like verify their code?
Yeah.
The changes?
Yeah,
They are not locally verifying, just initiate the push, and then if it breaks, then it is not push, and that's it, yes?
Yeah, so you know the developer dashboard that I showed? When you start that, it installs the pre-hooks automatically. So yeah, every time you type git push, it has to run the pre-hook. It's for all developers. Does that answer your question?
Yeah.
Thank you. Thank you, Neil.
Okay. Thanks, everyone.
Thank you.